Hello, this is Jeff Scott, and for my last presentation here, what I'm going to do is go over a PowerPoint presentation on threat modeling that I created myself. This is a culmination from a lot of the stuff I've read online and a few other things, but hopefully it'll do a good job of kind of bringing to a conclusion all of the different material that we've gone over thus far. So, I'm going to go through it fairly quickly because there are over 100 slides here. So I hope to do this in about 15 to 30 minutes. So what we'll cover: secure design, attack surface analysis, also known as ASA, attack surface reduction, also known as ASR, a little bit on risk assessment, privacy impact rating, threat modeling terminology, the purpose of threat modeling, the objectives of threat modeling, and we'll talk about the threat modeling process and really kind of a 9-point way of going through this. A little bit different than some of the stuff that we talked about in earlier presentations. So we'll talk about use scenarios, and then we'll gather some external dependencies. When you've got external dependencies, you also have internal dependencies. We'll define security assumptions. We'll create external security notes. And again, when you create external security notes, you'll also create internal security notes. We'll create one or more DFDs, and we'll talk about the components of data flow diagrams. Determine threat types, identify the threats to the system, determine the risks, plan the mitigations. All right, so that's pretty much what we're going to go over. So secure design, as it says right here, it focuses on good security hygiene within the application. Threat modeling is used here to determine the appropriate mitigations based on the found threats to the system. So in many ways, as mentioned here, threat modeling and secure design are complementary with one another. Some things to keep in mind: economy of mechanism. Again, keep the code and the design small and simple. Fail-safe defaults. The default should always be to deny an action. When you're not sure, always deny. Every access to any kind of protected object must always be validated. And finally, do not use security through obscurity. In other words, as mentioned, designs should not be secret. Separation of privilege and least privilege. Again, users shouldn't be able to work with any more privileges than they require. Minimize shared resources. And this thing here with the psychological acceptability. As mentioned here, is the product easy to use? In other words, is it fairly intuitive? If it's not, the chances are pretty good it won't be used. So let's talk a little bit about ASA and ASR. As mentioned here, the attack surface of a software product is the union of basically everything: the code, the interfaces, the services, and the protocols that are available to users. So attack surface analysis, ASA, is the process of going over all these interfaces and protocols and then executing code accordingly. Any code that's part of the attack surface is code that's more vulnerable to attack. So what you're trying to do here is to reduce the amount of code accessible to untrusted users. Notice here we're talking about ASR focusing on 4 components, and they're all in the reducing mode: reducing the amount of code executed by default, reduce the scope of who can access the code, reduce the scope which identities access the code, and reducing the privilege of the code. Reduce, reduce, reduce. So again, as you go from admin only permission to anonymous access permission, the threat of risk goes up. As you go from local access to remote access, the threat goes up. When you go through risk assessment, as mentioned right there, what you're trying to do is to identify a couple things, such as What portions of the project require threat models before release? What portions require security design reviews? What portions require pen testing? What's the scope of fuzz testing requirements? All this stuff that's in here that we haven't spent a lot of time on, it's because it's coming in future lectures. A risk assessment, as mentioned there, should result in a minimum of a security risk assessment and a privacy impact rating. Here's the risk assessment. So you're bringing everything together. You're trying to mitigate the threats that you have. Notice as it says, it's done by decreasing threat level or by eliminating or intercepting the adversary before they can attack. Privacy ratings, they go rankings from 1 to 3. Anonymous data is data that can't be tied to any one person. PII, which Microsoft and other agencies, I guess it's a pretty recognizable term, call personally identifiable information. And then you've got sensitive PII, things like social security numbers and other things that, if known, can really be terrible as far as breaching security, because they can lead to things like identity theft and fraud. All right, I'm just going to buzz through these quickly. All right, some terminology then. What's an asset? An asset can be abstract or it can be concrete, but as mentioned, it's a resource that the system must protect from misuse by an adversary. The attack path, a sequence of conditions in a threat tree that must be met for an attack goal to be achieved. A condition, a single action or a single weakness that must be present in an attack path for a threat to be unmitigated and thus become a vulnerability. Entry point, an interface that the system has with the outside world. External dependency, a dependency on another system. External entity, a system, user, etc. that exists outside of the system being modeled, but interacts via entry points. Pen testing, a test of the implementation of the system that attempts various attack paths. All right, so you're trying to either prove or disprove mitigation of one or more threats. Risk, a characterization of the danger of a vulnerability or a condition. Now again, I realize, because Doug Tabbitt went and spoke last week, that not every single thing that people, that not all of this terminology might be standard, it might be acceptable, it might be used by everyone. All right. Security strength, the effectiveness of the system at mitigating a threat, a weakness, and insufficient mitigation, usually resulting in a vulnerability. Stride we've talked about before. As it says, what an adversary will attain if the threat is exploited as a vulnerability. About the worst that you can get in there is elevation of privilege. Okay? A system is a collection of functionality that can span one or more components. A threat, the adversary's goals or what the adversary might try to do with the system. Threats always exist. Threat model, a document that provides background information on a system, the system's threat profile, and an analysis of the current system against that profile. So the profile, a characterization of all the attack goals that an adversary has for a system. Threat tree, this is an analysis tool. It can be visual, it can be textual in nature, and it shows all of the hierarchical conditions involved in the threats. Trust level, a characterization of an external entity based on how it is authenticated and the privileges it has. Notice trust levels can be and typically are associated with entry points. Use scenario shows how the system is intended or perhaps not intended to be used in deployment. A vulnerability, a security flaw in the system that represents a valid way for an adversary to realize a threat. Okay, so this stuff, let's just buzz through this quickly because it's all stuff we've talked about before. All right. Threat modeling is the act of creating a security design spec. As mentioned, if it's done correctly, it improves the security of the system and it improves the reputation of the system. So it strives, as it says, to understand the threat profile of the system, provides a basis for secure design and implementation, allows the user to help discover vulnerabilities, provides feedback for the application security lifecycle, as it says, given the purpose and functionality of a system, the threat model describes all the possible goals that an adversary has for the system. So you're looking at it from the outside in, as opposed from the inside out, meaning you're looking at it from the user's perspective, I should say the attacker's perspective. All right? You want to determine the security weaknesses of the system. This feeds directly into security testing. In fact, what you are doing with threat modeling is you're basically coming up with the points in the system that are most prone or most likely to be attacked. So that gives your testers a lot of extra capability when they're going through the system and when they start doing their testing. Identifies areas best analyzed during a focused security push or pen test. So here's the 3 steps. 3 high-level steps. Understanding the adversary's view. In other words, looking at it from the attacker's perspective. Characterizing the security of the system and determining threats. And that's kind of it. Now, when I printed these out, unfortunately, I took them out of a book, and no matter how I tried to turn it, it was a little crooked in the copier. But it's the same stuff that I just mentioned to you. As I've said previously, threat modeling takes an outside-in approach. Entry points are any location where data or control transfers between the system being modeled and some other system, typically some external system then. Assets, as we mentioned, are resources the component or the system has that the adversary might want to steal. They're the basis for threats. Trust levels, as mentioned, define how external entities are characterized for the system. They often deal with privileges assigned or credentials applied. So as we come through here, and we start to talk about characterizing the security of the system, as it says, this involves bounding the threat model, gathering information, and understanding the system. So you define your use scenarios, you identify your assumptions and dependencies, and then you start to model, typically through the use of DFDs. When you determine your threats, you're enumerating them, and you have to figure out which should be mitigated, which possibly should not be mitigated. You want to create a threat profile for the system where you identify the threats and determine how each potential vulnerability could affect the system. STRIDE is often used here. All right. It's kind of hard to see in here, but the bottom line is the threat model is used by security process managers, program managers, architects and developers, testers, direct code reviewers, pen test planners, and an assessment of the system security. Ideally, threat modeling will occur early in the process before code has been committed, typically before it's even been written. Why? As mentioned previously, this leads to significant cost savings. because the earlier you solve something in the process, the cheaper it is to fix it. You want to understand potential security risks, determine the risks, and establish any appropriate mitigations. More of the same here. It uncovers system threats before you've committed to code. It contributes to the risk management process. It revalidates the architecture and design. It forces the development staff to look at the system from a different point of view. In other words, from a security and privacy point of view. It helps clarify the selection of appropriate countermeasures, and it contributes to the attack surface reduction process. It guides the code review process, guides the pen review process. All right, so this data flow approach is going to lead us into talking about data flow diagrams in a minute. As it says, an application cannot be attacked unless an adversary has a way to interact with it. There must be some asset that it wants. All right? Entry points we mentioned previously are where control or data access in the system being modeled. So if you think about it, for example, the entry points for an office building. So if somebody wanted to get into an office building, what would they do? And these are the major ways, and if not all the ways right here. They could get in through a back door, through a front door, through a window. Through the water supply, through the gas supply. Again, a lot of different possible ways. Exit points, as mentioned, share similar characteristics with entry points. They represent locations where control and data moves between the system and the actual external world. So we mentioned this before. This is the 9-step process, which pretty much takes up most of the rest of the slides here. We'll talk about defining use scenarios, gathering a list of external dependencies, defining security assumptions, creating external security notes, creating one or more DFDs, determining threats to the system, threat types, identifying the threats, determining the risk, and planning your mitigation. So again, use scenarios, as it says. The threat modeling team needs to determine which key threat scenarios are within the project scope. Then they need to gather a list of external dependencies. As it says, these can be dependencies of a certain behavior or spec compliance in an external system that, if disregarded, could turn a threat into a vulnerability. The project does not operate in a vacuum. It's important to document everything and how everything works and fits with everything else in the system. You create external security notes. These are things that are basically are kind of showing warnings against potential use that can lead to vulnerabilities. These are things that you might want to share with the external world, and you probably will with your customers. You also have internal security notes. As mentioned there, describe choices made for business reasons, backward compatibility, and other reasons. So the main output of the threat modeling process will be your data flow diagram. All right. Now, as it says, a DFD is a graphical tool that depicts the flow of data and information into a system. Now, I want to change this and see if I can change this at least. So, don't know if it'll let me do any word art here or not. How about shapes? There we go. So let me get rid of this. I'm going to try to get rid of this. You sometimes see this shape right here. You sometimes see that for a process, but more often than not, all right, most of the time, you're going to end up seeing a circle. All right, and I don't want there. I want it to basically look like this. But let's see. I'm going to make it. I don't want it to be black on the inside, but okay. So that's what you want. And a process, as it says, performs an action on data. It can be manual or computer. It typically is circular. All right. A data store is usually identified with a database. An external entity is an origin or a destination of data, and a data flow is how data flows backwards and forwards between processes, data flows, etc. Now, a couple things. You need a minimum of one data flow going into and out of a process. A data store must be connected to a process, either input or output, or input and output. An external entity must be connected to a process. And a single flow of data must only flow one way. In other words, you can't have the arrow in both directions. Some mistakes people make when they do this stuff: you can't have two different things flowing out but nothing flowing into a system. All right. Data store, as it says, can't be hooked to an external entity. Here's what its sample DFD looks like, and it's pretty bad, all right, because it doesn't show up very well on here. All right, so let's quickly buzz through the rest of these. Again, the SDL threat modeling tool is the first threat modeling tool that's defined for both security and non-security people. As mentioned here, it allows the developer to do a lot of different things, and this is way too big a slide. I'm not sure why it's that big. Grab this. All right. It enables developers, it says, or software architects to communicate about security design, analyze designs, and suggest mitigations. This is how Microsoft explains the entire process right here. We've looked at things like this before. All right, so the tool includes a lot of different things: integration, a lot of automation, a direct tie-in with Stride, and reporting capabilities. And you've heard about this previously. A couple things, as it mentions there, that differentiate the SDL threat modeling tool from other similar tools. One, it's designed for developers. You could say security and non-security people. It's centered on software. Second, it's focused on design analysis. The Microsoft SDL approach to threat modeling is a focused design analysis technique. You want to identify the threats to the system by coming up with that threat profile. As known, or as stated earlier, to prevent a threat from turning into a vulnerability, you must mitigate it. This can be the most difficult part of the threat modeling process. Assets and threats have a close correlation, and a threat cannot exist without an asset. Threats cannot simply be identified. They have to be identified and they have to be analyzed. Typically, the analysis process involves using the Stride mechanism that we've talked about. You identify the threats to the system. You can use threat trees if you want. Threat trees, again, can be either graphical or textual in nature. Threat trees, Stride, are often used in conjunction with another Microsoft acronym that's called DREAD, that stands for Damage Potential, Reproducibility, Exploitability, Affected Users, and Discoverability. So what you typically do is you come up with something maybe like a 1 to 10 for both the Stride and a 1 to 10 for the DREAD. So if you had two 10s, you multiply one by the other, so the maximum number of points, so to speak, you can get is 100 as you're going through this process. You plan your mitigations. Vulnerabilities are ways of realizing a threat. All right, I'm going to skip this because this is stuff we're going to go over at another time. And those are my resources. And that's it.